Hello everyone. Oh, give me a second. That just noticed the screen. There we go. Hello everyone. Welcome to this video on similarity, kind of an introduction to similarity. So just kind of start off a definition of similarity. So similarity is similar to congruency, but not the same. So congruency, when two things are congruent, it means they're different. They're the same shape, but all the measures within that shape are equal to each other. All corresponding measures are equal to each other. That's what congruent means. Similarity is not the same. Okay, in my opinion, similarity is a little bit more useful in kind of real life situations. So similarity, definition of similarity, is when two figures are the same shape. Right? So for example, a triangle and a triangle. Same shape, and all their corresponding angles are congruent. So this angle is congruent to this one. This angle is congruent to this one. This angle is congruent to this one. All right. Part of that similarity is not just the angles are congruent, right? Corresponding angles are congruent, but also their sides are a common ratio. Okay, that's what we're going to be talking about a lot today, is the common ratio. It's also called the scale factor. So we got a little example here. Okay, we got this triangle 6, 4, 3, and 9, 6, 4.5. Right. Now, based on our definition of similarity, corresponding angles, they are congruent. All right, so that implies similarity. We each got to see if the ratio between the sides is the same for all three sides. If it is for all three sides, then these are similar triangles. Okay, when I talk about ratio, I'm talking about comparing corresponding sides, so 6 to 9, and creating a rational number or a ratio or a fraction, right? Rational number. So if we go in this orientation from the big one, or from the small one to the big one, from the small triangle to the big triangle, right? Then our ratio between our corresponding sides is 9/6. Okay. Now simplify that. Divide numerator denominator by 3. We get 3/2. Okay, that's the ratio between this side to this side. What's that saying is in my big triangle, let's say this is 9 feet long. In my big triangle, for every 3 feet I go on this side, I go 2 feet on this side. Right, it's common ratio. Let's try this side and this side. So 6/4, that ratio. Well, divide numerator denominator by 2. You get 3/2. Okay? So the ratio from this side to this side is for every 2 feet I go here, I go 3 feet here. Well, the ratios are the same. So that bodes well for us. Let's try the base here. We have 4.5 to 3. Right? Now you can divide by 1.5, numerator, denominator, or put it in your calculator and find the fraction. But it does simplify down to 3/2. That means the ratio between this side and this side is 3/2. Since all the ratios between the sides are equal, it's a common ratio, and that tells us that these two triangles are similar. Okay, they are similar because all corresponding angles are congruent, and all corresponding sides have a common ratio. Now, you can change orientation. What if I went, instead of from the big triangle to the small triangle, from the small triangle to the big triangle, from the big triangle to the small triangle? Well, the only thing that changes is these numbers flip. So my ratio becomes the reciprocal. 2/3, 2/3, 2/3, right? The ratio becomes the reciprocal, it flips, because my orientation flipped. Okay. Now, the importance of the common ratio, why it's called a scale factor, is let's assume that I don't know what these side lengths are. Okay, I don't know what those side lengths are. And my orientation is going from the small triangle to the big triangle. But I do know that my common ratio is 3/2. That's what I do know. Okay, let's assume this. I can find all these side lengths knowing the common ratio. Okay, knowing the scale factor. All I have to do to find this side length is take 6, multiply it by the scale factor. Okay? When we multiply fractions, we go straight across. 6 times 3 is 18. 1 times 2 is 2. 18 divided by 2 is 9. That side's 9, which it was. All right, let's try 4. To find this side, I take this side and multiply by the scale factor, times 3 over 2. Multiply straight across. 4 times 3 is 12. 1 times 2 is 2. We get 6. And that was that side length. Okay, let's try 3. So 3 times the scale factor. Multiply straight across. 3 times 3 is 9. 1 times 2 is 2. So 9/2, or written as a decimal, right? When we use length, we usually use decimals. 4.5. Right, so this right here, the scale factor, allows you to take an image and enlarge it by a certain ratio, okay, by a certain factor. Or if you change the orientation, if I change it to 2/3, it allows me to take a bigger object and scale it down, okay, shrink it. In fact, that's what cameras do. Okay, let me show you here. So if you're to take a picture with a camera, let's see, this is going to be a bad drawing, but here we go. Here's a camera. Here's its lens. Here's its lens. Let's say we're taking a picture of a tree. Okay, let's say the tree is 100 feet tall. Okay, well, what cameras do is they capture light that's bouncing and refracting off the tree. So light enters the lens from the tree, and light, it just keeps on going, right? Unless you interact with it, it'll just keep going straight. Okay. Now there's a lens here. What ends up happening, actually, is that the image of the tree, fun fact, is flipped. It's reflected inside your camera, and they put a mirror in there to reflect it back. So that when you take the picture, it looks right side up. Now, my question is, if you're taking a picture of a 100-foot tree, let's assume with your phone. Okay, take a picture of is it going to show, is the tree 100 feet tall on the phone? Well, no, right? It's, how big is it? Like maybe 6 inches? 6 inches tall, right? It's not 100 feet tall. So somehow that camera had to take 100 feet and scale it down. And it uses similar triangles. So if we create a triangle here, and a triangle here, these angles are congruent because they're vertical angles. This angle is congruent with this angle, and this one with this one. Okay? And so since these triangles are similar, right, all the angles are congruent, all the corresponding angles are congruent, there is a common ratio between all three sides. Okay? And what the camera does, and this is a very basic understanding of it, obviously, but it takes that ratio. Let's say instead of 100 feet, we want only 6 inches. So that's like that's the ratio, which is 3 over 600, which is 1 over 200. So there's its ratio. I think that was very quick math in my head. I probably did it wrong. Anyways, let's say that's the ratio, 1 over 200. So what it does is it takes every pine needle, right, every pine cone, every branch, every piece of bark, everything that is capturing the image, and it scales it down by a factor of 1 over 200. And so that the image that looks on your screen looks proportionate, right? It looks proportionate, but it's smaller. And when I say proportionate, assume that you're taking a picture of yourself next to the tree. When it comes on your camera, are you bigger than the tree? No, right? It still looks like the tree is much taller than you. because the camera scales everything down by a common factor. So everything stays proportionate, it's just smaller. Okay. All right. So that's what the common factor does, or not common factor, the scale factor or the common ratio does, is it allows us to scale an object. Okay, so I can take a triangle or any kind of object really, and I can enlarge it by a certain factor, or I can shrink it by a certain factor. And that's what it does for us. So let's look at some examples here. We have 10, 6, 8, and we have 12, 9, 15. And we want to find the scale factor, okay, the common ratio. We're going to find it for both directions. So we're going to go this orientation from the small one to the big one. So we're going from the small one to the big one. So these sides correspond, 15 over 10. Divide numerator denominator by 5. We get 3 over 2. Okay, there's your scale factor. Now it does say in the directions that we're assuming that the figures are similar, meaning we don't have to find the ratio for every side, okay, because we assume that they're already similar, so we know that the ratio is common. Now, if I did the other orientation from the big one to the small one, I would go, instead of 15 over 10, I could go, or I'd have to go, not 10 over 15, which is 2/3. So either of those answers are acceptable. Now, make sure you read directions on the quiz or on homework, things like that, because it'll tell you if I want a specific orientation, it will tell you. If I don't, it won't say anything, and either of these are acceptable. Let's do the next one. So this is 4, 6, 6, 2, 2, 3, 3, 1. Okay, so going from the big trapezoid to the small trapezoid, we have a base and a base, or we have the top of the top. I guess technically this is the base if it was a regular or flipped. Anyways, so 2 over 4. Divide numerator denominator by 2, we get 1 over 2. There's your common factor, or your scale factor common ratio. Man, that's the hardest thing for me to say. Reverse orientation. So 4 over 2, which is 2 over 1. And there's your ratio there. Okay. Let's go to the back side now. Okay, now I don't want to take up tons of time on this video, so I'm gonna stop drawing the shape. So you're gonna need your guided notes, just like always. So this one, this first part here, or this part here, says we want to determine if these two shapes are similar. So we don't know that it's similar, but it does show us. Oops. It does show us that all the corresponding angles are congruent. Yeah, that's what it does show us. But we need to figure out the similar, that all the sides should have a common ratio. So let's see here. Going from the big one to the small one, we got, or small one to big one, we have 18 over 12. Divide numerator denominator by 6. 3 over 2. Wow. Been using a lot of 3 over 2, huh? Then using base to base, we have 24 over 16. Divide numerator denominator by 8. 3 over 2. And then we have those sides. We have 8.7 over 5.8. Right now, if you put that in your calculator and change it to a fraction, you're going to get 3 over 2. All right, so all of the ratios are the same. They have a common ratio. So because of that, they are similar. Let's do the second one, this one over here. We're going to do this one now. So let's see here. We'll go from the big one to the small one. So we have 5 over 25, looking at the base, which is 1 over 5. All right, divide numerator denominator by 5. And then looking at the sides, 8 over 35. Well, that doesn't reduce. So it's just 8 over 35. Now these ratios are not the same. They're not equal, so the shapes are not similar. They're not similar. Okay. Now we're going to the second set of trapezoids, this one here. Let's see here. So the top there, we have 30 over 25. Divide numerator and denominator by 5. We got 6 over 5. The bases there, we got 48 over 40. Divide numerator and denominator by 8. 6 over 5. And the sides there, we have 26.4 over 22. Okay, now if you do that in a calculator, we should get 6 over 5. All right, so the ratio is common. We have a common ratio, so the figures are similar. Okay, let's do that last one there. We have 30 over 25. Divide numerator and denominator by 5. We got 6 over 5. And then the sides there, we have 36 over 35. That doesn't reduce. These are not, or these fractions are not equal. These ratios are not equal, so they're not common, so they're not similar. Okay, those are your answers. Okay. Let's go to that last section. So now this last section, we're trying to find a missing side length. So what we're going to have to do is we're going to have to find the common ratio and then multiply by the common ratio to our corresponding side to find the side length. Okay, so actually I'm going to draw this one. We've got here, 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 here. We have here, 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 here. And let's see, this is 35, 20, 15, question mark, 16, 12. All right, now notice that these shapes are rotated. They're not just reflections of each other or just a transformation. Well, I mean, it is transformation, a translation, excuse me, right? It's not just a translation across. So we got to find corresponding sides. Well, short side corresponds with short side, right? Now I want to find I want to find this side. Sorry, I went brain dead for a second. I want to find this side. So my orientation is going to be 12 over 15. Because I want this side, so I'm going to start here. So 12 over 15 is the orientation I'm going to use. Divide numerator and denominator by 3, I get 4 over 5. Okay, that's my common ratio. Okay, now I'm looking for this long side. So I'm going to use this side right here, this long side, 35. So 35 corresponds with the side I want. I take 35, I multiply by my common ratio, or the scale factor, 4 over 5. Let's see, 35 times 4 is 0. Actually, let's do it this way. We can cross-reduce, divide by 5 here, we get 1. Divide by 5 here, you get 7. 7 times 4 is 28. And that's your answer. Okay, let's do that next one. (24, 15, question mark, 10, 16, 14. Okay, so our short side is going to correspond with short side. I want this length here. So I'm going to go 15 over 10. Divide by 3 in the numerator. divide by 5 in the numerator denominator. 3 over 2 is our common ratio, or the scale factor. Now this side right here corresponds with 14. So I'm going to take 14, multiply by my scale factor, divide by 2 here, divide by 2 here. 7 times 3 is 21. There's your answer. Okay. Then let's see here. So this next one, it tells us the scale factor, and we're trying to find a side. 48. Question mark. And it says the scale from A to B, this is A, this is B. So from A to B is 5 over 6. So what I'm going to do is take 48 times my scale factor, or my common ratio, divide by 6, divide by 6. 5 times 8 is 40. And that's your answer. The next one. Got this. This is A, question mark. This is B. This is 48. So it says the scale factor from A to B is 1 to 6, or the common ratio. So I'm going to take 1 over 6, multiply by the side I know, 48, the corresponding side. Divide by 6, divide by 6. 8 times 1 is 8. And there's your answer. Okay, and that's all there is to it. So that's it for the video. Let me know if there's anything I can do to help you. I'm here every after school. Come and ask your questions. I'll see you next time.